right? So, so then, as I was saying, so for the MRU, there are certain programs, like for example, things that check upon the health of the PC and stuff, that need to keep data inside the memory for a long time, and that data is not really used very frequently. Also, that data is kept there. For example, if they need to check the health of the PC from the time they had left it, to compare what is the stable state looks like, then in that case they would need to keep the data in there for a long time and only be able to use it when they would need to check upon it, when they would need to check upon the health of the PC, which may be several cycles later. So in that case, the data that they are using will not be most recently used. So that is why it says that those that are using the data, which are, or rather, those data that are being used most recently, their uh, their importance is, or their importance is not as much as the data that are traditionally resided in there for a long time. That is why you replace them with MRU. Okay, so this is your most recently used. Now for the next one, optimal. So is this understood by everybody?
Yes, sir.
Okay. The next one is slightly different to the others, which is called optimal PRA, which is called Bellardi's or clairvoyant page replacement algorithm. And for this, you have to understand a few things. First of all, let's look at the names. What is the clairvoyant algorithm? What is clairvoyant? Has anyone got any idea what is clairvoyant? What is the phenomenon of clairvoyance? Do you know this?
No, sir.
Clairvoyance means being able to predict the future. Being able to predict the future. So, what the optimal peer page replacement algorithm does, it tries to determine, okay, what data is needed most or least, sooner or later. Okay. So it tries to determine which data is needed the most or least, that is most needed, least needed, sooner needed or later needed. That it tries to decide. Whenever there is a need for some chunk of data to be, that is obviously when you're bringing in a page, you have to throw out a page. Whenever you need a page to be thrown out, you choose it with that which has got, you choose it as that page which has got the data which is least likely to be used soon. That means it will be maybe needed much later, and it is least likely to be used anyway because of its comparative lack of importance. Comparative lack of importance, or but I mean, it can be both. I mean, for example, there are some very important data that is used only once. So once it is used, there is no point in keeping it in cache. So when you need to replace the page, the clairvoyant algorithm is trying to decide which is going to be needed next. And then when it decides that, it throws the one out that is not going to be needed very soon, or that is not going to be needed most. That means it throws out the data which is to be least needed and needed later on, or both. And or that is, there is an or there. I mean, either the data that is least needed or the data that is not going to be needed soon, or both. It throws that data out, or page that contains that data is thrown out, and a page that is required is then brought in. So are these algorithms clear to you?
Yes, sir.
Okay. So in that case, we'll call it a day today and have a nice day. On Friday, we will continue with these algorithms. We'll look at the Clearpoint algorithms and others in a bit more details. And in the meanwhile, obviously, I encourage you to look it up. And I obviously encourage you to look up the last day's classes as well, a bit more details. I mean, the calculations of how you do direct mapping, the calculations of how you do, that means what kind of tags, etc., you use using associative mapping, the calculations of the set associative mapping. I'm not just reminding you. I'll set that as an assignment, but before that, I'll take a presentation on that. In fact, I may take the I may do both. So basically, you just have a read through that. And this one also, I'm asking you to read up, keep it ready. If you have any troubles, ask me. And then obviously on Friday, especially with the optimal page placement algorithm, Belladis algorithm, we're going to discuss those and the others a bit. Okay. So for the time being, so do you have any questions
Sir, please, can you again repeat? You have said that we need to make a presentation.
regarding what I did on yesterday? Okay.
Okay.
I had told you the summary of the three cache mapping techniques: direct, associative, and self associative. What I haven't told you is the exact mechanism, that is the calculations of how you do direct mapping, the calculations of how you do associative mapping, the calculations of how you do set associative mapping. You need to read up on those, and I would want to ask you to present. So I can ask anyone to present any of the three, and then I will have you submit that as an assignment.
Okay, sir. So the basic concept.
No, see, basic concepts I've already given you. I hope you've understood that. You need to read the techniques up in a bit more details, okay, so that you can present it and then submit it as an assignment.
Okay. Sir, can you please repeat which techniques you have already
There are
used?
three techniques, not techniques. I'm saying about mapping. There are three types of mapping. One is direct, one is associative, one is set associative. These are the most commonly used. So you can just have